declarative pipeline is all about. So Spark declarative pipeline, or previously we used to call it as Delta live table pipelines. Mainly, these pipelines are used to build scalable pipelines without going for some of the issues related to like how we have to build each and every part of the pipeline. The pipeline is automatically going to be created. The only thing that we have to specify the logic, like how the pipeline is going to be built, but it will automatically going to be created. So to build this pipeline, either we can use Python or SQL code, whatever we want. And during each phase, like when we are going to use the Medallion architecture, so how we are going to utilize that, like from where we have to get the data, how the data will be moving to the bronze, from bronze to silver when we are doing some sort of transformation, cleaning the data and all, and finally moving the aggregations mainly into the gold layer tables. So this is what we have to do. So if we are going to proceed with the traditional approach, so there we generally what we do is like we have to build everything from the scratch, and uh, you know uh, basically configure everything, and we have to specify what will be my compute and all. But here you don't need to take care of all those things. The only thing is what pipeline is going to do, only that thing we have to take care about, and from where my data is going to be there. Because in the background what it is happening is the autoloader is working. So yesterday we have also discussed about the autoloader. So autoloader, what it does is like whatever the file or the the location that we are specifying. So there are different modes. Like if the data is coming as a streaming mode, so uh, automatically whenever the data is landing to any of the data lake, either it's going to be S3, Azure, or GCP, or anything that you have specified as your from the UC itself, Unity catalog path you are specifying. So automatically, whenever a new file is going to be picked, coming to the system, it will automatically going to trigger it. Or else we can make it as a triggered, like after one hour, 2 hour, one day, every day, at what time you have to you can just schedule those jobs as per your requirement. So, and if the job is going to be continuous, like if the tables are coming as streaming tables, so in that case we have to, instead of doing it as triggered job, we can do it as a continuous job. So this is our based on our requirements, right? So let me just share my screen. Let me know once you are able to see my screen. So I'm going to show you, like yesterday I created one job. So first, how you are going to create it. So you can go to this jobs and pipelines. So here you see three options are there. Either you can use jobs to orchestrate anything, like if you want to orchestrate anything, this will work. Then we have got ETL pipelines. This is what we are going to create, today. And the ingestion one. So ingestion one is just to ingest the data from sources to wherever you want to bring your data, and then further you can create your job. So ETL is extraction, uh, transform and load, as we have already nowadays, like when we are working with lakehouse architecture, so it is ELT, extract, load, and then we are transforming. So first we are basically loading into, this is the main difference. ETL is basically we are extracting the data, loading the data, transforming data, and loading the data finally into the. So basically, we are loading the data after transforming it. But when it comes to huge and diverse data sets, whether it's going to be structured, unstructured. So there, instead of doing this, so what we do is like first we are going to load the data. Means like here we are talking about the data lake, like S3, ADLS Gen 2, GCS, where the storage is cheapest. So we are just dumping the data into our data lake, and then we are transforming as per our requirement. So that's why when it comes to the huge data sets, then we are generally performing this ELT data loads. But if we talk about any of the ETL pipeline, so we can talk about, let's say, Hadoop is an ETL, or like Informatica, which is a warehouse. So that also uses the similar approach. But those works on Informatica and all these are all only for the structured data. As these are mainly the traditional databases. But if we talk about, let's say, Google's BigQuery, so that is that is a cloud, we can say cloud data warehouse, right? So you can click on this. And what you have to do is, like, when you are going to click on this, it will automatically ask you to give it a name to your pipeline. So you can give any name, like new pipeline name. So here you can specify the pipeline name. Automatically a file is going to be start give my transformation. So either you can have this, you can put any valid name mentions what your organization used to prefer, or as we know, like name should be like it should be very informative. Like from the name itself, we should be able to know what this is basically doing, right? So this way, once we are done with the our code, so either code you can write it in, right now it's by default Python, but we can also go in the SQL itself. So if we have got your code is in SQL, so you just change it to SQL, and then what you need to do is, like, you need to just run the pipeline. When you have just click on this run the pipeline, automatically what it will trigger a pipeline for you, and the pipeline will be created. So within the pipeline, you have to you will see the whole pipeline is created with this below you see pipeline graph is there. You like what is my how my data is coming. So initially I have got data into my transaction bronze, then from bronze to silver, and finally it is going to the final my table customer spending gold is there. So how this is getting created? This is getting created because of this code that we are using, right? Whole pipeline code is there. This is simple, and just one file code is there, but like here we have in a single file. But if you want, you can put, because based on the logic, because it's simple, here we are just using one table or two tables. We can, like, one data set, two data set, based on the on this we can use. But in real scenarios, the data is coming from diverse data sources. You have to the logic is going to be quite complex or very big, so we can maintain that into even in different files, like bronze file and silver file and gold file. So that's but if the logic is not that much complex, like it's not going beyond 1,000 lines of code, so generally we can put it in one file only, and wherever we are just going to put, so we have to specify with @DLT, or nowadays, like, if you can use DLT as well as SDP also, Spark declarative pipelines. So both work as it is, right? So first thing, what we have to specify, like what we are inputting, the DLT, right? So DLT is the, you can say, the legacy from where it is coming. So they have not changed it to this one, right? Then what are the functions that we are going to use. So those basically the libraries which are going to be used in your logic that you need to specify. The main thing comes here, right? You have to specify your path, like where your data is actually, like source data is actually landing from, where my processing is going to be start. Because once I have got this input is there, only then the data will flow from this raw, this location is my input location, is my raw location from where my data is landing to. So this is going to be my raw location. From here, then my next step is going to be so here what I've defined as at the DLT table. So here I'm specifying the name of the table, right? What table it is creating from the raw data. So it's going to my transactions branch. So this will create the data into table, my transactions branch table from my raw data, right? And let me show you the data also. It's quite simple as of now, but yeah, let me show you. So within this, if you see, I have got one transaction.csv file is there. I think that should be here. I should have opened it. Next. Yes. So this is my some transaction file is there, which have got some transaction ID, customer ID, amount is there, and what is my transaction date, right? So T1100, it's my transaction ID. C starting with customer ID, right? And then what is the amount, and what is my transaction date is there. Simple one, just to make you understand, right? So this is my table is there, and this table is there, as you can see. There is this my table. The location of this table is this volume, my catalog, my schema. Within my schema, I have got this test volume. Within test volume, I have got one. I've created one folder transactions, and within this transaction, we have got this transactions.csv file, right? This way we have to create the schema of this the folder structure, and then we have to do it. So every time, if let's say right now it's just transactions, but generally if we are doing it in this streaming data set, so it will come with like it's CSV. If it is coming as CSV, so it will either come with some a date some date format. Otherwise, like every time it is going transaction.csv. So 1 2 3, either naming convention should be like this. So whenever a new file is going to be there, so there should be some sort of timestamp attached to it, which will tell the autoloader, okay, this is my new file, and now I should take this file. So basically, if something goes wrong with the autoloader, let's say what the autoloader does is it automatically detects the new files and checks whether that particular files are already been or not. If that is not processed, so it will take that last processed file, and then it will start running on it. So that's why it's clear things that how the autoloader works, right? So autoloader, as the name is specified, I told you, automatically detects and do it. So how this is doing is like, so this is the name. You can specify any name. So whatever name you are, the table is going to be created with the name. Here you don't have to create any table in advance. At runtime, my tables are getting created. So the only thing is like you have to specify those names, right? So at the rate .dlt, at the rate DLT.table name, we have to specify, and this is just some comment like what it's the table is doing, right? Now, yesterday I told you like here we are using a spark.read stream, right? So it means like we are reading this file as a streaming. So in cloud, as I told you, you can also use files. So spark.read instead of read stream, you can just read the file formats we can specify. But what kind of read stream? Then file here as it is an autoloader. To autoloader format is cloud files. Then within the options, you can specify what is the cloud file format that you are using. So it can be CSV, it can be JSON, like, if it is coming in terms of, let's say, streaming data. So generally, streaming data comes in the form of JSON formats, right? Or it could be other, like if your files are coming from some database and those have been converted into Spark for optimization purpose, so you have to specify that. Then these are options are basically these, if as the specifies, options are options. So based on the file ingestion, they are going to be used, like, like header true, info schema. Those are not going to be like, header true is not going to be specified when we are using Parquet or JSON formats are going to be there. Right? From where I'm going to load it, this is my input path that I have specified above, and the with column. So this is going to be my metadata column. So this identifies the next time, like when this file has automatic got ingested. So this is we have introduced a new column. So whenever we are creating a table, so this new within that table, a new column apart from all other columns which are there as a part of this CSV. So we have got transaction ID, customer ID, amount, and transaction date. Apart from this, there would be one more column which is called an ingestion time, right? At what time, and its value is set as current timestamp. Like every time, whenever it is we are ingesting it, so it will ingest based on this current timestamp, right? This is so as you can see in branch, we didn't do anything, like no transformations at all. We are just reading the file from this input file path and then loading it with this one more column ingestion, right? Within the Silver itself, now here, as I told you, this is the layer where we generally have to what we generally do is we generally use to clean the data, right? Like removing duplicates, removing unwanted data, unwanted columns, or we are doing some sort of let's say cleansing the data, removing null values, removing negative values, if based on the requirement to requirement. So here same d@dlt dot table name, then transaction as underscore silver, and then what we are doing is here. So here we are just we are putting some validation. So here we just need to put @dlt dot expect or drop. It means like what is it is expecting. If that is not possible, it is going to drop it. So there are different other methods also. Like if you don't want to drop it, it will send it to some another table where we can just rescue table or other tables so that we can check them later. But here we are just doing it like expect drop. So when it is like when my transaction valid transaction ID. So if my transaction ID is not null, then only I'm going to expect it. Otherwise, I'm going to drop it. Another check that we have applied here is the valid amount. It means my amount should always be greater than 0. If my amount is less than 0, so that row or the record is also going to be dropped from my silver table. So these are the the rules that we have applied. But if we are not using this as a part of DLT, we are not doing it in the form of DLT. So in background, it is automatically checking and doing this with this expect or drop. But if we are doing it in the traditional, we are building our own ETL pipeline. So there we have to specify like where the transaction ID, either if we are doing it in SQL or if we are doing in Python. So data frame dot transaction ID should be greater than, it should not be null, and the valid amount should be greater than 0. Likewise, but here we just specified this way, right? So this is easier to build. Then within the silver table, what we are returning, so whatever the stream we are getting from the transaction branch, and we are also duplicating the deleting the duplicates. So this is another function which we have at part of Spark or PySpark in the Python, we have got drop duplicates, drop underscore duplicates. So there are two different functions. And then basically drop underscore duplicates, we can't specify this on which column we have to do it. So it will automatically take all the columns and then check for the duplicates. For using drop duplicates, we can specify on which columns we need to check the duplicates. Like, so we are here only checking on the transaction ID. So if transaction IDs are going to be same, so it is going to delete those dropping those transaction IDs wherever we find. So if you see here, there are a lot of transaction IDs, right? The 3 is there, 2 is 1, then 3, 4 are twice. So 1 and 4 are some duplicates we are having, right? So these should be dropped. Then here we are specifying the schema. So by my transaction ID, I'm casting it to string. Customer ID is string, because by default in CSV everything is considered as string only. But my amount, transaction date, so and ingestion time, so we have already taken as timestamp, so that is not required. But the data that is coming from the CSV, so by default everything in CSV is string itself. So that's why we are just changing their data types, because if we are doing any sort of if we are not doing the amount to double, so how it will calculate amount greater than 0, because it will take it as a string, right? So it will not be able to do the comparison with greater than sign. Greater than is a it's an mathematical comparison operator. So that way we have to do it, right? Again, like transaction date, if you want, we can keep it in string itself. But yeah, it should not be, because some in in most of the cases we are going to use this transaction date for the some sort of conversions, or that is going to be used in some sort of filters and all. So there it might create some issues, or if it is in, or we have to do the formatting on date. So if it is already in date, so we can do a lot of formatting methods are there that can be applied later, right? So that's what. And the gold layer, right? So in the gold layer itself, you don't need to do anything. Again, specifying what is going to be my table name. And gold layer tables are for the aggregation part. So that's why we are just taking it as. So we are reading now in the gold layer from where we are reading the data. So we are reading it from the transaction silver, then grouping it by on the customer ID, and aggregating what sum and count. So we are aggregating the amount on sum and calling it as total amount spent, because for each customer, right? You can see there are 3 customers, so 500, 250, 250. So this person has specified lot of amount, but here the data can be it could be some issues with the data itself, because we cannot have same transactions should be different, right? Customer ID can be same, but transaction can be different for each of these, right? And then finally we are just doing it. So once you have done with this, so when you are going to do it run pipeline, so what it will do is, like, it will create this graph. Now it is already been done, so that's why it is showing. But if you are doing it for the first time, so it will show you your progress, like how this is getting created, right? So you see here my output records were 9, here output records only 4, and here also 4. So in the silver layer itself, we have removed all the if you see here, we have got 9. So out of 9 on transaction ID, I think we have got 3. So these 2 are removed. So remaining 7. And then One is also removed. So 3 removed from here itself. Then in another, we have got 2 amounts are, 2 amounts are, so these 2 are got removed. So total 5 removed. So that's why we have just, sit with only last 4 records. And now we can go and check these, whether these tables exist in our, so you can see we have got bronze transactions. So this was my initial table. Transactions bronze, transactions silver. These are the tables. So this is my transactions bronze. Transactions bronze. Yes. So see, these are all, 9 records are there at what time, and this is rescued for, like if there is any issue with the data, so that this will come to here. Amount, you can see they are null for 2 values, so these are also going to be dropped as per our. So if we go to the silver transaction silver, where the checks has been applied. One is transaction ID should not be null, and another one is, and we are also duplicating, dropping the duplicates based on my transaction ID. So 3 transaction IDs were duplicated, so those got removed, and for which we have got the amount was null, those also got removed, right? And finally, if you see, customer spending gold, user spend, it's customer spending gold. It's customer spending gold is my final table. See, so total transactions, now it is showing only 1, because what was the issue? So can you identify the issue in this data? I got one issue. Yash, Sharmila. First tell me, like, whatever we have discussed so
As
far.
per transaction date.
Yes. Okay. Yash,
Your voice is not coming, sir.
I'm not audible.
Now you are
Hello.
audible, sir.
So yeah, what I was asking, like, did you find any issues in the
Sir, I think they consider transaction date as one.
no. Basically, what it is like we can have the transaction ID should always be unique, right? So what is happening for this client, customer C101? He did 3 transactions: T1001, T1001, T10. One for 5,500 and the rest two for 250. So total amount for him it should be 1,001, right? But what we are getting in our final table, just it is taking the first because it has dropped the last 2 records. Why? Because if we go and check our logic here, so first thing what we are doing is we are dropping on transaction ID, right? So for each customer, you can do, like say you are going on a retail store, right? And you purchase 10 items. So for those 10 items, the transaction ID are going to be 10. 10 different, transaction IDs are going to be there for one customer, right? So the issue is like we have to have, like if we are going to change this, so this should be customer ID 2, this should be customer ID, transaction ID 3, right? Now, if we are going to run, and for 2 is there is 4, yes. For 4, this should be customer ID, let's say, transaction ID 1 and transaction ID 2, right? And now, if we are going to run this again, now we will get, they are going to be, some aggregations. Because right now, there is no aggregation is happening. Final thing, if you check here, in my final table, what I'm getting, I'm just getting one transaction. But for our customer C101, there should be 3 transactions, and I should get amount as 1,001. Same for C004. Rest of the two, that's okay. Those are fine, right? But data, right? So now I want it, any one of you should try this right now, right? Because it won't take much time. I'm going to share the code and I think this file also or data also with you, and then try this. So who want to try this? Let me just first share this data, right? Pipeline. So first tell me, like, any questions, any queries? Transition for CSV. Okay, let me send you these also because later those are also going to be used. And New file coming. Okay, so similar way, I've created a one more pipeline. You know, if you go to jobs and pipeline, so here you will see like this is another Medallion ecom pipeline is there that I've created. So here instead of one, we have got two input files are there. One is my users and another is my transactions. And then again, that is going to to my silver layer where it is for this it is creating metallized view, it is creating a stream table, and finally the gold layer as my metallized view. Right, the logic is almost because it's a approach for this also. And if you want to do any sort of edit things, schedule this, you can do it. So if you go to the edit pipeline, system seems to be a little slow. I don't know, maybe some network issue today. So Sharmila and Yash, just tell me first, like any issues, any concerns, any questions so far? So if you see, like this is my source path, my files. So within my files, if you see, we have got two, folders are there, user and transactions. So this will automatically fetch the data when we are using user. So it is taking the data from there itself, creating a table bronze users with cloud files, right? And here we have got the as JSON. So here we have to specify the path, right? Last time we have just specifying the because there were only we have specified the full path as we were having only single folder. So that's why I just specified that source path, and I was putting into source path as it is. But now this time it is source path and users, because if you go and check this one, within my files we have got two folders are there where my files are. Yeah, so my user file is here. So every time a new user file is going to be there, so it will reside here as like users underscore 001 002. Likewise this will come, right? So this is the standard procedure. Like, or else if we want, we can have those files based on the timestamp and date also. Like if on the basis of, let's say, daily file is coming, so we can put it as with the date. Or if continuously files are coming, let's say my streaming job is there, so definitely those will come with timestamp, because within few within seconds itself, or within milliseconds, my files are arriving. So based on that timestamp only, it will get to identify, okay, these are the new files and that need to be processed by the autoloader itself, right? So same is should be for itself. This is transactions file. This is different within the transactions itself. So these are very some few things that we have to just keep in mind when we are developing our code. So again, the code seems to be almost similar here. We're just loading it with ingested at the current timestamp. Then within bronze transactions, next we are taking as bronze transactions, and in bronze transactions we are reading from the transactions itself, as we are reading two sources from two different folders. Then it will come to the silver table. Then again, for silver users, we have got silver users. Again, we are applying expect or drop, where the email should be a valid email, like it should have @ or it should have some sort of dot. Then only it is allowed to. So here we did the email ID, right? Because it's a user. So then here we are taking email ID. Format name, then row number, based on the row number, we are just saying row number. Based on row number, we are partitioning based on the user ID, and ordering it by on the updated column, so that there might be the case that there different users are going to be there, and we are going to deleting those rows with the same user IDs. So which is going to be the updated one? You see, we are ordering by updated at with descending order. So it will only going to have the latest record for that user ID, right? The rest we are dropping, right? Because we are filtering based on the basis of row number equal to 1, and then rest we are dropping. Then in silver transactions, we are saying we only need validated positive transaction amount. So where the positive amount is greater than 0, that data will be only bringing to. So this is the filter that we are applying as a part of transactions table. And finally, in the gold table, as we are using two different tables, so here we have to do some sort of join, and join is going to be used done only on the common column only. So wherever we are having the common column, only that column we have to do the join. So here we have created two different data frames. One is users data frame and another transaction data frame, from where we are reading the tables silver user clean and silver transactions, right? And finally, what we are doing is we are joining transaction data frame with user data frame based on user ID. And how we are doing it? Using inner join. So here again you can specify different joins: inner, outer, left anti, left semi, based on your requirement, like what kind of requirement you have. Based on that you can do it. Then we are grouping it by whatever the the data we are getting after join. That data we are grouping, because finally in gold layer we have to do some sort of grouping. So we are grouping based on user data, user ID, email and name. So here we are not using only single column, here we are using multiple columns in grouping. And then what we are aggregating? We are aggregating the sum of total spent by each user, transaction IDs, what is the amount on based on counting the sum on transaction ID, and saying is what is my transaction count is there, and the transaction time, which is going to be my last active time, like what. So it will take the latest max time for that particular active user ID, right? And then finally returning the summary. So in this, if you see the graph here, so based on your number of inputs and outputs, this graph will always going to be little more complex. It will see, but it is easier to understand. Like it's not that much complex once you are going to put your hands dirty. So definitely the things will be in your favor every time, right? So any questions, any queries so far? Yash,
No, sir.
all good?
So
Yes.
this codings will be already be in the real time projects. There will be these codings will be available.
Yes,
So
yes. This
we
the
need.
logic we have to write, right? This is this
Mhm,
is
yeah,
the one that
yeah.
the only thing that we have to do, right? Because the logic is not going to be same for all. But right now, if you talk about the code, the only thing is like we are going to utilize the the AI for that, right? If you are not able to do it, so you can do it. That's completely fine. It's not a big blocker. Just give me a minute, right? I think there is someone at the door, so just give me a moment, right? I'll be back. So, who want to try this? Whose system is up and ready for doing this test to create this pipeline, or shall we proceed? You are going to do it later, guys. I need
So
your,
one more, from my understanding, Raj, on
hmm?
one I have. So
Later, sir.
from my
Later.
understanding,
Hmm?
Later. Later.
Okay, you want to do it later. No worries. So, okay. So this way you can just create your pipelines and based on your different use cases.
so
So,
you hear me, Raj? I have a question.
mhm.
So, from my understanding here, this silver and then gold, right? In silver, we are cleaning the data as it is mostly similar to this one, right? Apart from removing the duplicates, do we do any other
Yeah, a lot of
actions?
transformations we do. Like whatever the transformations you are going to do, most of the
Okay,
transformations we are going to do in the silver itself, right? So it's
okay,
related to like removing duplicates or removing nulls, or you are changing something. You are adding some columns, removing some data. So most of the things we have to do from the within the silver layer itself. So it's all based on your requirements.
yeah, yeah, I understand. Yeah, so
So if
so
you
all
even
kind
if
of
you
transformations will be done there.
yes,
Okay,
yes, yes, exactly. So even if it's not like this is for Medallion architecture, we are following the three medals schema for now, like bronze, silver, and gold. But as I told you, it's not mandatory. If you want, you can put more steps within this, like even within after bronze you can put one more one more layer before silver, or you can put after silver, or even after gold. I told you, like we have got some companies even following platinum and then diamond also. So based on the how they are enriching their data sets, right? Like even
So who
after
will decide? The developer will decide this one?
no, this is all decided by, like, this is all business rules, right? The rules are
Mm-hmm.
decided by the business, but developers are to implement them. So we are here
Yeah.
to implement those rules, but the rules will always come from the business itself. But there are a few rules with basic rules. So even basic rules are also defined in the the ticket, or the whatever the document that you will get as a part of your development, right? So those are going to be cleared at that point of time, like what we exactly we have to do. The only thing is, like, whatever they are giving us, we have to convert that into either in Python or SQL code, and then create that
So
pipeline.
the business will be giving the requirements, and then the developer will be
Yes,
implementing it.
exactly.
So
This is
my question here is like, do we need to tell the business that we are we going to can we add the layer here, or is that how it goes?
yes, definitely. Like it all again. This is very good question, and based on the the requirements, if the things are coming. So generally, what the business do is, like, based on the requirements, they will specify, okay, within this layer we want this data, within this layer we want this data. But if they only want the final result, they don't care about in intermediate
Layers.
layers. They don't
Mm-hmm.
care about that, and they want, okay, I just want the finished data should be there, and we need the optimizations. This is our main requirement. So definitely we can
Okay.
remove the
What is the pros and cons of this layers? So if we add some more layer,
yeah,
will it affect?
definitely, like, yeah, let me come to that point. Like yesterday I think we discussed this thing, but yeah, let's so if we are doing the things in in layers, like why we are adopting this medallion architectures, because it has got a lot of advantages. One advantage is, like, as we are having in bronze layer we are having raw data, right? Whatever data. So if
Mm-hmm.
something goes wrong in my silver and diamond gold layer, so I can go back and check every time, right? And
Mm-hmm.
change my logic as per my requirement, and then run the pipeline again from the even from the let's say last 2 months, 3 months, whatever from where I need to make the changes, and I can run it. This will be one time, and then continuously run it. So this is one way. And this is a lineage also, like whenever we are having some sort of issues, so through this lineage tracking we can also find out the issues again. The second thing is, like, some organizations, they don't only need the final data, like gold layer, or whatever their final layer tables are there. In between, let's say silver layer, some another client wants to, they don't want to ingest the raw data itself. They want some finished data, and as per their requirements, the this silver layer is fulfilling their demands. So they can directly use that data and those tables, and on top of it they can perform their operations, whatever transformations they want to do. Another point, like, again, it will always go to the bronze layer also. Like some teams, they want to ingest the data, they want to do some fresh transformations which are already not there in your silver and gold layer, so they can utilize that way, right? So it is always beneficial to go by step, because, like, if I'm doing everything in the one step, so might be first thing it is going to be quite complex, because here each and every layer we have got the roles are the tasks are defined. They have got so if everything going is good in at the bronze layer, I know everything was good at the bronze layer, I've checked it. So next time I want to go back to the bronze layer and check, okay, because I know at the bronze layer I've got the raw data as it is, what it is coming from the, so I'll check my logic at the silver layer and the gold layer itself. If I know, okay, my silver, till my silver layer my data is fine, so I can go and check in the gold layer itself, uh, identify the issue, update that logic, and run it this way. So basically here's this we have got proper separation of logic is there. So whenever we have got this strategy, so even debugging becomes quite easier, right? Because when we are doing it in a single way, so the things are going to be complex, and when the data is going to be too large, so the business logic is also going to be complex. So when we have got these division of logics are there at different layer, so it always gives better performance, better readability, better debugging facilities are there, right? So it's always better. Any is your question answered?
So
Yes, I think so. So what I understand is if we are extending the coding, going to be tough when we run the pipeline. So it is always follow the procedure and running by layer is
Yes,
good, is what I understand,
exactly. It
right?
is always better because first thing is like even if when you are developing it, if you are putting your logic everything in one layer itself, so it is quite complex to debug it. Because here what we are doing is we are doing very simple things, right? But in actual scenario, you won't see those things are going to be simple, right? I told you
Mhm.
like I have got just one workflow which is having initially it was an Alteryx workflow. When I converted it to Databricks notebook, it was having around 8,000 lines of code. So just debugging that 8,000 lines of code, how much time you think like it will take? Even I tried with AI also. It was not able to work for more than 7 to 800 lines of code. It was just little confused, giving it was just trying to update here and there wherever it is find, okay, this should be the case, but the whole scenario it was not able to understand. So this way, but what I did is then I modularized all the things. Now my pipe the code has also reduced a lot because Alteryx was using a lot of code reusability. Like it was deduplicating duplicating the code at many places. Like same code it was duplicating at 8 to 10 times. So why I'm using those same function, whenever it was implementing a new way. So that was totally wrong. So I reduced the code to 3,000 lines of code, and I just did it in you know uh, created my library for that, build a utility functions. So wherever, let's say, I was calling reading an Excel file. So in my there were around 1,500 different files were there, and out of those 1,500, we were having around 50, 60 different sources were there from those files which were coming, and different file formats were coming. So every time I was calling, so it was calling the same code, same. So what I did, I just created the utility for that. Whenever I was calling that function, just passing my file name itself and whatever the parameters were there, and I was able to do it. So this way we can reduce a lot of things, right? Similar way, when we are modular, approach is always better, right? Yeah, sorry. Yes, you were asking something. I started in between.
yes, sir. Have you, sir, you are doing the same thing all on all day basis. If you have you ever created any a layer between bronze and silver?
In my current organization, they are following this medallion architecture, and in another project, basically, we have got like here we have got.
I want to know that
Yeah.
you find you are facing this kind of situation ever or not?
Yes. I have just when I was in this DBS Singapore. So in there they are not used like in three layers. They are having even diamond layers, which is especially for the business users. They only need few reports, and they have their defined formats are there, because they don't want to see the hundreds of reports. They want to see some fixed reports. What is the what generally they just wanted to see few of the statistics, like just going through those statistics they get to know what is going to be their next plan. But before the below this level, whatever the the business peoples were there, they need reports from the from gold layer itself. So it all depends. Definitely, like I'm not saying this thing by using assumptions. Whatever I'm telling you, either I've faced, I've worked on this, and I know like a lot of people or a lot of organizations are using that. So yes, so whatever we are discussing here, those are all in real world. They are getting used, right? Clear?
Okay.
Okay.
Okay. So okay, fine. So you are going to do it. Okay. You can just try it. And what I will do is, if I get some time, so I'll share you few very small use cases with some uh, sample data. But I'm not going to share with you the logic. So this time you can build your logic, right, based on the
Okay.
the files. So that will help
Mm-hmm.
you out, because every time if I'm giving you the the running code, so it is not going to work, because every time when you are going to run it, it will run, and you will not be able to identify the issues. Because if your code is having some sort of issues, then you will get to know the actual scenario. Because in real scenario, if I'll show you here itself, like I'm running my current job, right? Even I'm running it from few months. If you see these red ones, right? Still it is failing, right? The code is fine, everything is fine, but still due to some infrastructure issues and all, I'm getting some sort of errors. So this job runs for around 4 to 5 hours, and at last point of time it like it fails. And why it is failing? Like bad request, because it was not supposed to. My warehouse serverless warehouse would not get started. It got an error. Otherwise, it was running fine, right? So until unless you are not working on it, you are not actually creating the logic, running it on your own, then you will not be able to identify the real issues. And I want that until unless you are not facing the real issues, then it is going to be quite difficult in real scenario, right? Because then it will be like very fairy tale, right? Everything is working. I am giving you the code. That code is already I have fixed it. It was working fine. Then you will not be able to got those errors. But in real scenario, on daily basis, what we do is we fix the errors. Every time we are fixing the errors, right? It's very rare that you run you created your code and it run without any errors at the first place. I think with me it never happened, right? Even the code is perfectly fine, few other things doesn't run quite smoothly. So there are a lot of things apart from this coding and all. When we are moving into infrastructure, we are running our code with multiple services, different jobs we are running. So there might be a lot of issues, but yeah, these things will be cleared when you are start building those things, right? So you will get to know what kind of errors you are facing, what is the solution for that those errors, right? So this is how we have to do it. Now let me share you one document that I was supposed I'm going to tell you like some optimization techniques. These are very really required. So this I was just searching on Google, so I found one very good document. This is for like if you have not subscribed to this, I think I will ask you to subscribe to this medium. This is here you will get a lot of very good examples generally, so to understand what is actually like a lot of people's put there. So I got it on everything in just one document, so that's why I found it like I should share this with you. You can just this is really for the optimization purpose, right? So there are a lot of optimizations that we are having as a part of Spark as well as Databricks. So here let's talk about few of the Spark optimization techniques. So as I told you, this is one of the you know the major or the major chunk of our development part, because just building the pipelines is not it's here our task doesn't complete. The main thing comes that we have to optimize, because if my data is pipeline is not optimized, data is not optimized, then definitely it is going to cost us a lot. Yesterday also I give you an example, like one of the pipeline is taking around $12,000 a month, so it's a huge amount. So we have to optimize it and bring it cost down to below $2,000. This is our first thing, and without making most of the changes in the code itself, because we don't want to make the changes in the logic, because that logic is what they have running it for 5 to 6 years, so they are fine with it. The only thing is, like, they need to optimize it. The pipeline they have built it, whosoever has built it, but at that point of time they never think about, like, this is going to create the mess like this. So instead of like where we can have few hundred or even few lakhs of records, they are bringing billions of records every time they are running the job. So these things are very you know not good at all, because the data that we don't need it, why we are bringing it for the processing, right, which is not going to be used in our final reports. So that those things we have to understand. Okay, so here we'll first talk about the file format. So we have got different file formats are there, either CSV, JSON, Parquet, Delta, ORC, Avro. These are all only most of the file formats which are supported by the Spark itself. So as we have seen, I told you, giving the example for CSV, JSON. So these are our traditional file formats are there, and these are not optimized ones, because they store the data in the form of row oriented storage like CSV, or we have got Excel. They all or even our databases, they all use this row oriented storage. So my data is going to be stored in this format, right? Let's say row 1 is going to store employee 1, department, range. Similar way we are going to store the data. But when we are going to pull the data, let's say I'm having 100 rows. So, and I just wanted to bring the data, let's say, for 10 rows. So when 10 columns. So my process is going to, when we are using this row oriented storage, so it will fetch all 100 columns for those rows. So it will scan all those data. So the scanning is going to take a lot of time. But when we are going to deal with, let's say, Parquet, Delta, ORC, these are all row oriented, column oriented data stores are there, which stores the data in this format, like column. So column 1, like all the employees are going to be there in one column, department in another column. So if, let's say, I have here, he has given an example similar way, like if they have to pick only 4 columns out of 1000 rows, so it will only going to bring those 4 columns for those, not all the rows. But in this case, it has to bring all the rows. It has to read all the rows and then filtering the data based on, let's say, I've got 100 columns were there, and it has to pick only 4. So that way it is going to first storage is going to be increased, and then also when we are reading it, so that's why it is going to create a lot of impact on my performance itself. So this is one way. So mainly that's why when we are working on any of the let's say if you are working on Databricks, so any of the other either you are using Azure Databricks or any other platform also, there the default format is Parquet. So my storage, like when I'm just storing the data without specifying my format, so it will always going to store the data in Parquet format, right? So that's why it is more optimized. And we know that whatever transformations we are doing in Spark, we have already discussed this. These are all lazy evaluated. Like until unless we are not going to hit any of the any of my action functions, my job is not going to start. It will only create a DAG, that is directed acyclic graph. So if we are doing, let's say, select on a data frame, we are selecting ID and result, and passing the condition dot where result is greater than 70 and ordering by result. So I am not going, this data frame is not going to trigger any job, or any task is not going to be triggered until unless we are not going to put any, you know, these action functions like count, collect, show, display, or save as. So there are many, so once we are going to hit any of the action functions, then my Spark job is going to be started. Until unless, it is not going to work. We have already discussed this thing earlier, but yeah, just to give you a brief about this. So again, transformations, as I told you, this will create only the directed acyclic graph. This thing we have also discussed. Transformations, we have got two types: narrow transformations and wide. In narrow transformations, basically happens within the one partition only. So there is no shuffling of data happens. So that's why narrow transformations are faster. Let's say we are doing filtering, we are doing some map functions we are applying on a data set. So those are very narrow transformations. Here the shuffling doesn't happen. But wide transformations, whenever my data is ended up with multiple partitions, so my data, when we are crossing it, when we are doing any sort of join aggregations, so there itself the data need to be shuffled a lot, because similar kind of data might be the case, like this as you can see, I have got data for these colors. You can see some different IDs can be there. So for this ID, data is, some data is there, some data is there, some data is there. So for another ID, some data is there, some data is some data. So when we are going to reshuffling, means redistribution of data is going to, and this is the most expensive operation that we are having as a part of this. So when we are doing this thing, group by, sort, join, these are all gives me where the shuffling happens. But if we are doing just select, filter, cast, or union, so here these are some narrow transformation operations are there where the shuffling doesn't really require, right? So they do it in this way. So this shuffling is really a bottleneck, right? And really bottleneck comes generally when some of the partitions have got low data and some of the partitions are having large data set, right? So in that scenario also it will correct. So you see here, you can always go to the Spark jobs, and there you can specify, see that what is your how many number of jobs have created, how many stages within each job has been created. So that way you can see. So if we are just doing filtering, so you can see stages one by one. So there are no more stages are there. But if we are doing any sort of wide transformations, so here the number of stages got increased a lot, right? So this is how the processing is happening in background, right? So see here we have started with 4 partitions and end with 4 partitions only. So there was no shuffling at all. But if we go to the wide transformations, so you see we have started with 4 and how we have ended up with 200 partitions, because by default when we are shuffling the data, so the default number of partitions that we are having is 200, and here there are 2 stages has been created. So different stages are going to be worked with and that's why this is a bottleneck. So to handle these partitions, there are 2 ways, like either we can go with the repartitioning or cols. So in cols function, we can reduce the number of partitions, but in if we want to have the proper distribution of data, then we have to go with the repartitioning, and within the repartitioning we can only we can decrease and increase both the number of partitions based on our requirement. But by default, as I told you, if you are not specifying any partitions, so by default it creates 200 partitions. Even if my data is, let's say, in MBs only or even KBs only, it is going to create those many number of partitions, which are really not required, right? So partitioning and partitions, as I told you, this is one of the very important method in when we are doing the optimizations, right? So this is how, this is one another way of, optimization techniques called catalyzed optimizer. So now this is not, you don't need to, use this, because this is automatically been implemented in our AQE, that is adaptive query execution. After Spark 3.0, it is automatically now, we have to just enable it in 3.0, but after 3.2 onwards, even we don't need to optimize it. It will it is inbuilt by default, and by default it is enabled also. So what it does is, like, previously we have to implement these things manually, but now we don't need it. So what we have to use it, like, whenever we are going to a query, so an unresolved logical plan is created, and then on this then some analysis happens, and it checks whether the schema is correct or not, and then a new analyzed logical plan is created. It basically, what it does is, like, it checks if the schema was correct, then the driver will add respective data types to the column. So here we are going to add respective data types, and then comes the this catalyst catalog. This checks again, like, what is my, from here the logical optimization starts. Like, then based on this, two types of optimizations are there. One is my rule based, like, based on filter, join, which operation should going to perform better if we are going to apply filter first or join first. So it is always better, like, if we know, like, when I'm just loading the data and I have to do a join, let's say I'm having 1000 records, but if I'm filter the records, and after filtering I've just got, let's say, 200 records, so my join is only going to happen on 200 records. It will not happen on 1000 records. But if we are doing the join first, so a lot of shuffling is going to happen, because 1000 records and 200 records you can compare, right? So that way, because when we are joining it, so sometimes it happens the join is happening in the form of a cross join. So cross join explodes a lot. So 100 multiply 100, so those are going to be 10,000 records, right? This way. So if we are having 1000 and 1000, so it will be 1 million records. This is the the power of, like, how we are going to optimize it. So basically what it does is, like, then two types, physical plan is going to be evaluated. So optimized logical plan, then physical plan. So these physical plans are created, and then once this physical plan is created, so at the runtime it selects one of the best physical plan, in the sense that which is going to take best effective cost. Then it comes the CBO, that is cost based optimizations are going to be selected from the best best physical plan is going to be selected. So previously we have to do it this ways like this. If we have to enable the cost based optimization plan, enable true. But now we don't need required, even join recorded, enabled, reordering. These things we have to specify manually within our code itself, or within the configurations itself. But as I told you, with the introduction of AQE, that is adaptive query execution, from Spark 3.2 onwards, it is enabled by default. But prior to this, it was introduced in 3.0, but we have to enable it, right? So now these things are going to be automatically enabled, and you don't need to do a lot of things. But few of the things, like what kind of join that we are going to apply, predicate push down, like where we have to apply the filter, we have to apply for where we are going to apply the filters, those kind of things we can do it. But most of the things now, they are being handled from the AQE itself, right? So here one example has been given. Let me show you. See, it is creating 200 partitions. And what was my data size? Just 240 kbs. Is that really required to have that much amount of? Just for 240 kbs, it has creating 200 different partitions, like around 1 point some kbs in bytes, not in kbs even, bytes in one partition itself. So this is really bad. One was there. So if we have to work on that, we have to specify how many number of But after doing the AQE, so now you can see it just creating just one partition, right? So this way we can do it. Now we don't have to take care of all those things. These are all being implemented. But yeah, you have to understand these things, right? You have to understand this, right? Because sometimes in interviews itself, like even I ask these questions, right? Because to understand whether the candidate is having that much of understanding, even though these things are now running in background, but we should know how exactly the things are working. And sometimes we have to even optimize the plans also. So based on our requirements, if something comes up that we have to optimize these things, so if we know the logic, then only we can implement those things, right? So that's why I'm just giving you the. Then this is another predication push down is very important. Like whenever we are filtering, so we have to filter the data from where the data we are getting it. So this is called the predicate push down. Like we have to push our data down from where the data is coming from, like from the source itself. If we are able to reduce the data from the source itself, then definitely it is going to perform better. Let's say I've got different transformations are there, as we have discussed, like from bronze to silver to gold. So if I know, like I don't need get data from in the silver or even the gold. So what I can do is I can just filter records at the bronze level itself. Those are those which I don't really need it, because in some of the cases uh, I don't need that data. So what I can do is I can just stop the data at the bronze layer itself, because although I'm having every like my data is available in the raw bucket itself, right? From raw to bronze, we are just we are not doing any transformation. We are bringing the data as it is. But if we know that, okay, or else, like if we know okay, I want all the data in the bronze, but I want to filter only get the filter data at the silver layer. So I can put that filter at this silver layer. But yeah, we have to based on our requirement, if we are going to do this predicate push down, is to reduce or bring the filter where we have to minimize the data as much as possible, right? So this way we can just do it, right? Just go through it, and if you find any issues, because these are very explained very well, but even if you find any issues, I'm here to help you out, right? So there are some of the best practices that we can apply. Again, caching is another important practice to store the the intermediate data, which is getting used in multiple steps, like down the time you are going to use the same data frame multiple times. So it is always better to put it in you can cache that data. Cache is basically it's a as we know, it's very expensive memory. So most of the data every data we cannot put it as cache. But like this particular df is getting used in my let's say next 10 transformations. So it is always better. So it will not going to get that data every time, read it, bring into the data frame and use it. So within the cache is the fastest memory available, and it will fetch the data very fast. So and whenever you have you don't need that data,
just unpersisted. Otherwise, it is going to will always be there in the cache memory until unless your session, you are in the session itself, because cache memory will remain until unless your job is is up and running. But if in that case, if you don't need that data, my product one has been done, and I don't need that data after this particular point of time. So that then I can persist so that cache can be used by some other data frames itself. Correct? So by default, as I told you, we have discussed this thing also, like the number of partitions are going to be decided by the data size and the divided by 128 or 256 MB. But default is 128, but we can always change it from the config itself, right? So like we can get df.rdd.get number of partitions. So this will always gives me the number of partitions that we are having. So here, if you see, we are getting how many number of partitions are there? 4, right? So, but even if my data was supposed to have more number of partitions, as I told you, the default partitioning that we are having is now here we have set the partition size, right, as 200 MB, and number of partitions, shuffle partitions to 20,000, right? So based on because my data size was 400 terabytes, and I've just bring it to 200 MB, so it will coming out to be 20,000 shuffle partitions. So this way we can also set, but default, as I told you, it will always remain as 200. So like when we are dealing with 400 terabytes of data, so it's a huge amount of data. So definitely it will not going to fit in 200 partitions. So there we have to put. So there they are just checking like, okay, my one block of data is 200 MB, so that's why. Or you can put it as 256 also. So it will reduce some number of partitions, right? Clear? Clear? Any questions? Any queries? So as I told you, adapt query execution has resolved all these tasks, or dynamically it is going to do it for you. So you don't need to take care of all these things as of now. But yeah, it will always creates the partitions. But even in some cases, we generally stuck, like some partitions have got less data, some partitions have got more data. So there we have to do some sort of optimizations or removing those skewed data itself. Clear? So as I told you, like there are two functions, repartitioning code. So repartitioning, we can increase and decrease the number of partitions. In repartitioning, the data is redistributed. Again, whole data is going to be redistributed. But in calls, basically, we generally used to reduce the number of partitions. So sometimes in calls we can get some uneven partitions can be there. But in repartitioning, it is always going to repartition with equal data sets, right? Yeah, so also go through these join strategies. Default is my shuffle merge join is there. Then I told you, we have got shuffle hash join, and another one is the broadcast join is there. So this is another important join that we have to apply. The first two joins are basically the default, and the that sort merge join is default whenever we are joining large data sets. But when we are dealing with joins where one data set is small and one data set is large, let's say one of my table is having 4 terabytes of data, and another some lookup table is there which is having just 100 MB, less than 100 MB or 100 MB till 100 MB, we can utilize that as a broadcast join. So generally 100 MB is a big data. When it comes to lookup tables are there, right? Very small tables are there, some. So those tables we can pass as broadcast. So instead of just reading every time and shuffling the data, it will directly go to those executors and broadcast the copies to that directly. So there are no need to shuffle the data, right? So in that way, it really creates a lot of difference when it comes to optimization. So this also method like I was talking about the optimization part, there were around six tables were there that were having data less than 100 MBs. So even 100 MBs, the data was less than 1 lakh records were there in few thousand record 12 since in some 10,000 records and in one table it was around 84,000 records were there. So those tables we have put it as broadcast join. So that also reduced the cost up to 20 to 25%. So this way, these are some of the ways that you can check what are the different optimization techniques, and this optimization is one of the favorite topic of any of the interviewer, because they always want, okay, the people can build the pipeline, they can create the pipeline. The only things comes like how you are going to optimize it, how you are going to reduce the cost. That is the main purpose of any organization, because they want to reduce the cost based on so these were some of the optimization techniques which comes from the Spark point of view. There are few optimization techniques that we can utilize from the Databricks point of view, which is like we can use optimize command. Like optimize basically co-locates all the files or small files to make a big chunk. Like this generally happens when we are dealing with streaming files. So streaming files, like in 1 minute or even in few seconds, a lot of files are getting generated, and those files are in KB size. So similar kind of files, they are going to merge. Optimize is going to create a merge and try to compact in one GB file, so that, because as the number of files are growing, their metadata is also growing. When the metadata is growing, then the seek time is also increasing. So to reduce that seek time and all, we merge those files. So this optimize command is very important. Then we have got liquid clustering is there. Now it's a very latest concept is there, where z ordering was there. Z ordering is we generally used to do whenever we are working with static large data sets, but liquid clustering is dynamic way of doing the clustering, and based on our data set, it automatically detects and do the clustering. So these are very latest. Another one is the Photon engine, which is the part of our compute is there. Like when we are creating the compute, so let me show you. Like here actually, this we are not supposed to create it, but generally when we are creating any compute, right? So here we should get that option when we are creating the cluster. So Photon, although it like if I am normally creating the cluster with one node, so 1 or 2 nodes, so it generally takes 1 dBu per hour. This is the cost that generally comes, and in 1 dBu it is going to be around 25 cents to 40 cents per hour that is getting charged. But if we are going to use Photon engine enabled, so it will be getting doubled, 2 dBu per hour. So it will automatically going to, but in some cases, especially when we are running with SQL queries, so Photon engine is very good. Like if you were previously running, it was taking around, let's say, 2 minutes to run the query. The Photon engine, when I can do it in 15 seconds or even 20-30 seconds based on the the data sets. And so definitely there, if you are even increasing, here you are decreasing, but you are decreasing in the way that still you are able to save some cost. So that way there are a number of optimization techniques that we can apply. We'll talk about it once I'll show you, like I'll try to show you how we can create a cluster itself, right? Let me show you.
cluster animation database. Okay, this is the step that they are showing. I just wanted to show you if you are able to see something. Yeah, so these are the, like I'll show you there itself, I think. These are given as not in pictures. I thought like there will be some pictures so I can show you. Here we don't have any pictures available. No worries. But this is very straightforward and very easy to, how we are going to do it. Like auto scale is there, auto termination time, attributes, clone from. You can also clone it from another ones, right? What is going to be the custom names if you want to specify some tags. So locker images driver. If I show you here, it should be like what is going to be, whether you want to do it in single node, multiple node, you want to use ML runtime or not, how many number of workers are going to be there, what kind of policies that you are going to apply, single Spark users, Spark version, cluster ID. Okay, those photon and all are some advanced, things. So these are not covered here because by default it's not going to photon. But yeah, let me photon, yes. Photon engine. This generally works better when we are having SQL queries. So this is next generation vectorized query engine is here. So this generally works when we provides massive speed while maintaining 100% of compatibility with Spark APIs, right? So this is very good when we are performing SQL operations. You see, delivers up to 2 to 8 times faster performance of SQL. So that's why it is better. We enable Photon mainly when we are working with, let's say SQL queries. Mainly we are dealing with SQL queries, right? So that way you can, increase your performance. And apart from this, there are other ways or also. We'll discuss once we are done with, because once we are having all the things in place, so optimization is really very important. One of the key factors that really judges your performance. Okay, any questions so far, anything that you need to understand, didn't get, please let me know. Any inputs, any thoughts? I need your inputs.
So from me, it's like session for the next week is also done. They need to take some time and then I
Yeah,
think I have
definitely.
to.
I'm not saying right now, but whatever we have discussed today, do you have any questions over it? Anything that you want to understand it again? Let me know.
I need to go through again. So
Okay,
if I have
fine,
questions,
fine.
I will come.
Yeah, got it. Okay, and let's stop it here, right?
Yeah.
I've already shared you those, files, and okay. For another one, I need to share the code also for where we are using this users and transactions one. Okay, and then I'll share you a few of the data set only, and then you have and the use case. Then you have to create the notebook, right? DLT pipeline for that, right? But
Okay.
now you need to do the practice. Otherwise, we will end up with finishing everything, and you if you are not practicing the things, so maybe after a few days, few months, you forget everything, right? So I don't want to happen this thing. So just start practicing from today itself. Uh, it won't take much time. Just an hour is enough, right? And I don't think that you cannot spare just 1 to 2 hours a day, and that should not be the case, right? But yeah, you have to do it initially, and then uh, gradually move to you know increase your number of hours, because you have to do it, right? Okay, anything else? Any inputs? I think we are then good, right? Thanks everyone. Have a nice day, nice weekend.
Thank you. You too. Bye.